if that makes things quicker. Otherwise, you're welcome to draw them in. Firstly, let's recall what a histogram is, because today we're looking at how to display numerical data. And of course, we're going to spend a lot of time looking at numerical data because it's far more interesting than categorical data. Alright, so histogram, remember, if we have 30 to 34.9, then there is one person in there, it goes up like that. Important features are labels here and here. The y-axis is always frequency. X-axis must be labelled. You will do it neatly with rulers and you will connect your graph. The reason it's connected is because the numbers flow on one to the next, from 35 on to 36, etc. So these need to be connected. Alright, so key features of a histogram. We can have two types of evenly distributed data. Evenly distributed like this is a single peak. So single peak, this appears so often we call it normally distributed. And we'll spend an entire week on this later on. It's in the next couple of videos. So that's normal. This is quite unusual, but in theory it's still symmetrical because you can imagine a line of symmetry down the middle. This is called bimodal, meaning there are two modes. So, continue down. Now we can have skew for histogram. We can be positively skewed or negatively skewed. I'm not sure how you want to remember this. This one, remember, is positive skewed, neg. The way I remember it is, if we wanted to make it equal, we would have more columns on the positive side, so it is positively skewed. You could also think about it as a tail. This end's the tail. It's on the positive side, so it's positively skewed. This is a negative tail, negatively skewed. Just words we use to describe the distribution of data. So if you're asked to describe the distribution of data, you'll either say it's symmetric, normal, this, symmetric bimodal, positively skewed, negatively skewed. Here, for example, we have one that is negatively skewed and contains an outlier. Outlier is one that lies clearly beyond the others. Center. Now, center in a histogram can be quite a complicated thing to find because you're not told the raw data. For example, here, we're told there is one person between 15 and 20. There is two people between 20 and 25. There is two people between 25 and 30. So, one way to visualize where it is, you want to find a line, a vertical line that you can draw on the histogram that splits the area of the histogram in half. So, with this area here is equal to the sum of that area there. Another way I like to think about it is, imagine each one of these is a stack of bricks, and they're lying on a plank. There's the plank. And you want to place a fulcrum, so place something underneath that plank so it balances perfectly. If you put a fulcrum there, it would balance perfectly. Now, a more mathematical way of finding the mean, and you should know this although it's unlikely to be asked it, is what's happened is between 15 up to but less than 20, 20 up to less than 25, we have the frequency, which is 1, 2, and so on. So we can head down saying, well, there's 2, 2, 3, 5, 4, 3. And I won't fill in down here, but you can imagine down there. Now, we aren't told where this one person falls between the 15 or 20. They could be 15, they could be 19.9999. So what we do instead is we guess whereabouts they would fall on average. And on average, we say, well, we can't see it. If we can't see exactly what it is, let's pretend they fall at the midpoint. So the midpoint of that is 17.5. Next one up is 22.5, 27.5, 32.5, 37.5, 42.5, 47.5. So what we're saying is that one person scored 17.5. It's probably a lie, but on average it's the best we can do by looking at the histogram. We're saying that 5 people scored 37.5. Now that's not true. We know that 5 people scored between 35 and 40. We don't know where exactly they are, so we just guess, well, they're all 37.5. And then what we do to work out the mean from here is we calculate the mean of all of these. So you can do this very quickly on your CAS. And I'll bring up the CAS and show you. So what I've done here is I've entered the midpoints in the table and how often they each occur. And what we want the calculator to do is, well, essentially this sum here. We want it to do 1 times 17.5 plus 2 times 22.5 plus 2 times 27.5 plus 3 times 32.5, etc. All the way up. And then we want to divide by the sum of the number of people involved. So 5, 8, 13, 17, 20. We want to divide all of that by 20 to find the mean. And clearly we could do it by hand or with a calculator here would be okay, but with far higher frequencies it will take a very long time. So instead, or higher number of frequencies, we go to our CAS and we go Menu, Statistics, Stat Calculations, 1 variable statistics, number of lists 1, midpoint is the X list, frequency I labelled frequency, and then go OK. And that first one there is our average of 35.75. And we can see that that is where this line falls. Which is nice. Alright, so that's a way to visualise the mean, a way to calculate the mean given a histogram. What about the median? Well, a median is the middle number. So if we lined all these numbers up, we would say, well, there's one lot of 17.5, well, there's 1 in that bracket, and then there's 2 in the next one over. So we would have a 22.5 and a 22.5. And we want to try and figure out, well, where's the middle one? Now, the middle one, if there are 20 altogether, is, well, between the 10th and the 11th. It is, and then we count in. Well, where does that fall? So this is 1 in total together we're 3 in. Then here we're 5 in, 8 in, 13 in. So the median would fall in this bracket as well. Alright, got a lot to get through in very little time. Spread. Wide central region, narrow central region. Range, of course, is max minus min. And lots of this we do on the calculator, so you need to become very good at using your calculator to generate statistics quickly. For example, say we're given 40 students, and I always highlight 40 because I know that I've got to put 40 data points in at the end. We're asked to count the number of red cars they saw on the way to school one morning. The results are as follows. We want to create a histogram, we want to create a box plot. So please, as you're taking notes, write down the instructions of how I'm doing this, because I will go too quickly, but you'll need to be able to do it independently later on. So feel free to pause, write down the instructions. Alright, so I've entered them in earlier. These are our red car columns. Let's say I want to go a histogram first. Red car there, and enter a histogram. So I go Control I is to insert a new page, and I want data and statistics. Comes up with a lot of dots. Down here, I want red cars. Now that's effectively a dot plot. It's not quite a histogram yet, so we go Menu, Plot Type, because we would like it to become a histogram. Now, guidelines for histogram. We want, if we're after a histogram, between 5 to 10 columns. So, if we look at our calculator, there is far more than 5 to 10. We are going from 5 all the way up to 50, so I think it would be sensible to have our bracket size, or the bin size, as 5, because that way it'll get us our guaranteed 9. Alright, menu, we want to go plot properties, histogram properties, bin settings, so we want to adjust the bracket size. We want to have an equal bin width, and we want the bin width, instead of being 2, to be 5, and the alignment is the first one in. So instead of starting in 3 in, here we'd like to start 5 in. So we'll go from 5 to 10, 10 to 15, 15 to 20, etc. Okay. And if you feel like some have fallen off the top of the screen, you can grab here and drag down. The grab on your calculator is press and hold the middle hashtag thing with your thumb until it grips, and then drag it down. And you can see a beautifully drawn histogram. And you can see the modal category is between 20 and 25, and there are 9 points in there. Alright, let's say we wanted to instead create a box plot. If we want to create a box plot, back here again, we'll go Control I, insert data and statistics. We want, once again, red cars. Instead of dots, this time we want menu, plot type, box plot. Lovely. You can hover over for minimum, lower quartile, median, upper quartile, maximum. There are no outliers on here. Alright. We'll go back in more detail and look at these in more detail later, but right now it's important that you can produce them and can start to interpret them for the test next Friday. Alright, so we can get a lot from those, but what we can't get from a histogram is a measure of spread. So if we go to our TI, we can look at it and say, well, it looks kind of spread out, but there's no immediate measure we can use. Box plot is a bit different. We can say, well, the interquartile range is 16.5, because that's Q3, take Q1. I'm assuming you know what these terms are. You will need to know what range and interquartile range are. And we know the range is from anywhere from 48 to 5, so the range is 43. So how do we do this with a histogram? The measure of spread we use for a histogram is something called standard deviation. And I realise I'm going a little over time. Apologies, we're nearly done. Alright, standard deviation. So standard deviation we can calculate from the original screen here. In fact, we have to do it from here. We go menu, statistics, stat calculations, one variable statistics, listen OK, and then we want red cars. OK. X bar is 23.6. In fact, here is one I made earlier. One thing you should be checking is that n equals 40. N is the number of data points you put in. X bar is mean. This is add them all together. So if we add all the red cars all the students had, that's sum of all. You won't use that very often. This is sum of them all squared. You'll never use that. This here is what we use for standard deviation. Now, this one, so SX, think S, standard deviation, that's the one we use, that's good. You'll note the one below it is similar, will always be similar. It's best way to describe it, an alternate measure for standard deviation that we don't use in this course. If you do methods, you will, and you'll have to use them both. Sorry to confuse you, but we don't use that one. N, 40, then comes your box plot information. Min, lower quartile, median, upper quartile, maximum. And you should know, for example, that 50% of the data falls between these two numbers, and 50% of the data falls between these two numbers, and 50% of the data falls between these two numbers, because they each cut them up into quarters. This is the sum of squared. Don't worry about that. Sum of squareds. Alright, so we have looked at two measures of centre, mean and median. When do we use which? Alright, in a symmetric distribution where there are no obvious outliers, either can be used. Mean is more common, but either can be used. When the distribution is skewed or there are outliers, it's appropriate to use the median because the median is not affected by skew or particular outliers. And we note that when we use the median, we use this set. Interquartile range is built around the median. Range is associated with median, and we use box plots to show it. When we use the mean, we use the standard deviation and use a histogram or normal curve, which will come up. All right. And I believe I've spoken for more than long enough. Apologies that went so long, but you'll need to know how to use your calculator to grab a set of statistics and create either histograms or box plots and then be able to interpret them. We'll work on interpreting in class. Thank you very much.